Okay, the final type of transformation that we're going to be looking at are stretches, and they can come in two forms. They either come in the y direction, okay, or in the x direction. Now first of all, we're going to have a look at a stretch in the x direction. Now we've got a graph here. I think it's best to probably do it through example, and this is the graph of y is equal to x squared minus 9. Okay, so as you can see, the intercept is minus 9, it passes through 3 and minus 3 on the x-axis. Now if you're going to do a stretch in the x direction by a factor k, for example, okay, so a number k, then replace x, okay, because that's the one we're dealing with 1 over kx. Okay, so it's 1 over the factor times by x, and any time that the x turns up in the equation, you replace it with this. So say I was going to look at this graph in particular, and I was going to stretch it in the x direction by a factor of, I don't know, a half. Okay, then I'm going to replace x with 1 over a half x. So in other words, replace it with 2x. So think of it as 1 over a half. 1 over a half x is equal to 2x. So I've got y is equal to 2x all squared. Be very careful of that. Take away 9, which is equal to 4x squared take away 9. Okay, so that means it's still going through minus 9 on the y-axis. The intercept has not changed. What has changed is that the graph has been squashed. Okay, so we did have x squared minus 9, we've now got 4x squared minus 9. Okay, so that means that when I'm actually squashing the graph, it'll look something more like this. Okay, so it has been squashed inwards. Now it's still a stretch, it's still called a stretch, and always call it a stretch by a factor of a half. Okay, however, make sure that you don't write down squashed. Okay, so the intercepts, because I've stretched it by a factor of a half, the intercepts are now 3 halves and minus 3 halves. Okay, now if you're dealing with a stretch in the y direction, okay, it works in much the same way. If you're doing it by a factor k, then replace y with, as before, 1 over ky. So let's say we want to stretch this in the y direction by a factor 2. Okay, now the original equation is y is equal to x squared take away 9. Now I'm going to replace y with 1 over ky, or in this case 1 over 2y, 1 half y. So what you get, if you multiply both sides by 2, is y is equal to 2x squared take away 18. Okay, so y is equal to 2x squared minus 18. The intercept is now down here at minus 18, and the graph has got narrower. It's still going through minus 3 and 3, Oh, this is not looking good. It's a bit pointy, but regardless, it's still going through -3 and 3. Okay, however, it has been stretched in the y direction. Okay, so the intercept has been stretched out. You can see it quite clearly at this point that this almost part of a circle, it looks like, has been stretched downwards. So the -9 has become -18. Okay, it's as if this was say like a piece of rope or a piece of elastic, and I've suddenly put a weight in the middle and it has stretched the elastic down. Okay, so that's how you can see it. So just to reiterate then, with a stretch in the x direction, you've effectively got y is now f of 1 over kx. So notice how we're dealing with x in the x direction, okay, and it's inside the bracket. Notice how with the y direction we can write this as y is equal to k f of x. Okay, because 1 over k y is equal to f of x, and you just multiply both sides by k. So y is equal to k f of x. We're in the y direction, and what's happening is outside of the bracket. Okay, so this is little things to pick up on that are common throughout the transformations.